welcome to Design in the Age of Experience 2019. It is our contribution to this fantastic design week in Milano. And overall, our goal here is to testify once again. I think it's the third year we show up at the Design Week in Milano, our dedication to harmonizing products, nature, and life, which is Dassault Systèmes mission. And there is a lot of conversation in Milano, in the design community in particular, about the importance of sustainability in everything that we do. Our conference will be organized in themes. Every day there is a new theme, and we will bring on stage a testimonial of our customers. Today the theme is material, is matter. And of course, material matters. Material is very important and is the tool, the favorite tool of designers most of the time. Why is it important? Because material, as we all know, is a finite and scarce resource. So for us, there is a new concern about the sustainability around everything that we do. Also material, in particular natural material, teach us a lot of things. Nature is very efficient in the way organize material, creates material, grow things. Biology is an amazing machine, and recently the design community has embraced the design procedure and process of biology. In fact, we call sometimes the things that we do, our customers do, biomimicry. So anyway, very, very exciting. I don't want to spend more time on general introduction. We talk about material and we talk about the design, how design is important in designing our future. Design is not only important in creating things, but also creating ways of life and new ways of creating and consuming things. So let me introduce to bring a very amazing testimonial to these themes. My guest today is Matthew Fiedler, who is the founder of Re3D, a very innovative 3D printing company. Matthew, please join us on stage.
Thank you very much. Thank you very much for the introduction. I'd like to share with you today 3 short stories. A little bit about myself, the company Re3D, and then our vision on 3D printing in the future. So myself, I was raised on a farm in Iowa in the middle of the United States. And very early on, I was attracted to tools and building things. And I earned a degree in tool making, manufacturing engineering, and then later biomechanics and biomedical engineering. I took my education to work at NASA's Johnson Space Center in Houston, Texas. And it was here actually that I met my co-founder of Re3D. You see, we were both volunteering with an organization called Engineers Without Borders, NASA Johnson Space Center, and we were traveling around the world to places like Africa and Central America. And everywhere we went, we found piles of plastic waste. And we asked ourselves this question: why can't we take this plastic and put it back into a machine and make something useful at the human scale, things that truly address human needs? We pitched this idea to an incubator called Startup Chile, and they helped us found our company. We spent 6 months in Santiago, Chile, building our company, building this prototype 3D printer. And we put the 3D printer online to a website called Kickstarter so we could crowdsource our funding to start our company. And in 60 days, we had raised $250,000. You see, on the market at the time, in 3D printing hardware, there existed very few choices. On one side, you had the small desktop machines, which are great for making bobbleheads and iPhone cases. And on the other end of the scale, much larger machines, industrial machines, but they were cost prohibitive. There existed nothing in the middle. And that's where came our platform technology, the Gigabot 3D printer. In the last 6 years, since 2013, we've created a family of products. At the center of that family is a very interesting machine that now accepts recycled material or pelletized, ground-up plastic and allows you to 3D print directly from that. We have a range of machines that will print something about the size of a small refrigerator all the way up to more than 1 meter cubed. And I will say that, very importantly, as I tell these stories, one of the things I'd like to convince you of today is the importance of the digital threads and the digital tools that we have, and such as the Dassault Systèmes software, and putting into the hands of people not only the software from Dassault, but also the 3D printers. Because by democratizing this technology and allowing people to be creative and solve their own problems using these technologies, it allows them to make a positive impact on their communities. When we designed these platform technology, it would not have been possible without the Dassault Systèmes software. We were able to have a digital thread all the way from the ideation stage to the design to the manufacturing of our product. And now, with the 3D Experience platform, we're able to put our 3D printing services online as well. So launching 6 years ago with Startup Chile, we've garnered a number of awards for our products and services. We've been able to form collaborations and partnerships and spread our word through incubators. We have also received recognition and funding through National Science Foundation, and we work through the Global Creator Awards competition. You see, we have, in the past, since 2013, had a global presence and now have customers and machines in over 56 countries around the world, which actually puts us in a very unique position to understand the technology. We have a very close relationship with all of our customers, and so we understand the successes and the challenges that people are facing with the 3D printing technology worldwide. And how are people using this technology? It really runs on imagination. We have to imagine what do we want to make and then allow the machine to make it for us. Everything from education, which is purely one of the most important parts of the technology now. As a new way of manufacturing, we need to educate people on how does the technology work, how can they capitalize on it. All the way to art, design, and architecture. We see 3D printing as the bridge between our imagination and the world around us. It allows us to take our ideas and put it into a physical object that we can hold. Research is a very important place as it allows 3D printing to capitalize on the strengths of uniqueness, the customization, the personalization that you can obtain with the technology. Of course, prototyping, which is still one of the largest uses of the technology, to healthcare, manufacturing, and beyond. I would like to also share a couple of examples of what our customers are using. The best way for us to tell our story is to share the story of our customers. So also in Houston, we have a customer called Make Studios that is creating all the way from the ideation stage to the final product, using these digital technologies for installations. The next short video I'll share is an artist who's using on a larger scale the 3D printing technology. Here we'll see 23 pieces that were 3D printed with a total weight of more than 140 kilos, assembled into a sculpture that's 4 meters by 3 by 2.5 meters, and using a very durable materials of polycarbonate. It's pieces like this that really show the freedom of imagination, the freedom of shape, what you're able to do with the design process to bring those ideas out into the world around us. But we do everything we do because of our relentless focus on social responsibility. At the heart, when we started our company and asked, why can't we recycle that plastic waste? We also provide a very close connection to our community through a GigaPrize competition. We actually give away 3D printers. So for every 100 machines that we sell, we give one away to someone in the community that's doing something good. We ask that you make a small video, put it online, and we don't choose the winner. We actually let the public vote who deserves to receive this machine. So we have past winners in the Kayabera slums in Africa, in Kenya, who are using 3D printing technology to teach digital tools, to teach manufacturing, to teach entrepreneurship. We have machines in South America with a gentleman who's creating myoelectric prosthetic arms, as well as other organizations that are doing prototyping for flooring that go in refugee camps, realizing that a very small thing as having a floor inside of your tent can provide so much health benefits for people. So these are truly people that are making a positive impact in their community. The last thing I'd like to talk about is pictures like this are becoming far too common in the world that we live in. Why can't we take this trash and use it as a resource? And so that's exactly what we're doing. At the center of this, we have our Gigabot, a machine which almost quite literally can make almost anything. And traditionally, these machines run on a coil of plastic filament. But we see that as not the end, especially as we start to make much larger projects. Why can't we take this plastic waste and put that into the machine? So with the help of the National Science Foundation starting last year and the WeWork organization, we've been able to prototype and design and build a machine that directly accepts ground-up plastic. So I ask you, if you had a machine that can make almost anything and make it at the human scale, what would you make? Thank you.
Thank you, Matthew. This is very interesting. I took some notes. I think my attention was immediately attracted to this concept of circular economy for several reasons. One, you started this adventure of Re3D in Santiago, you said. We were in Santiago. We are very active in the maker community, Fab Lab community, and there was a worldwide convention in last year, two years ago, in Santiago, Chile, and of the Fab Lab Foundation. And the discussions, the talks were all about creating circular economies. And in fact, we have founded a few Fab Labs in areas of the globe that are very sensitive, and where circular economy can really make a difference. One example was Bhutan, 2 years ago. Bhutan is a small country nested in the northern side of India that keeps a very close tab on the way they organize their society. And let me make an example. They don't have the Minister of Gross Developed Product. They have a Minister for happiness, for happiness of the people. So they are really measuring this type of indicators. And they want to realize to keep their happiness of their society by living simply and producing locally what they consume locally. This was also the manifesto of another big event in Barcelona, of the Fab Lab as well, where the mayor of Barcelona said that in 10 or 15 years, they wanted to realize a type of economy where they create locally what they consume locally. So how does it relate with the mass production? Okay, as engineers, we have kind of perfected the science and the technology of mass production. Now, 3D printing is kind of putting that in question. What is your view of mass production versus circular economy and the values that those things bring to society?
So the real power of the technology is the opposite of mass production, right? So it's mass customization. So if you have a machine, you can create a one-of-a-kind object much quicker, much cheaper than any other manufacturing technique. As you said, we've been able to make a lot of something, right? But having a lot of something may not be as interesting or beneficial to people, but having something that works better for you because perhaps it's customized for you, it's personalized for you, that's the real power of the technology. And to create something different. Oftentimes, when I ask people that question that I asked everyone, if you had the machine and what would you make, it's not an easy question. And it comes to be, it's very difficult. Many people will look around them and say, well, I'll make that coffee cup or something, and I say, no, 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 no. That's not the power. That's not the utilizing the technology. You can make a coffee cup that is different than any coffee cup that existed, or perhaps it fits your hand better, or perhaps you need some assistance to eat and drink, and you can use the design technology to design something for you. So we need to think in terms of mass customization. With 3D printing, you can make one of something, 100, maybe 1,000, but it's not mass production. And I think as we wrap our minds around that and think about how can we open up the freedom of design on a small scale and to make appropriate things for each people, I think that's where the real power of the technology comes in.
Appropriate things for each people. You also show the video of the use of your 3D printer to create artwork. We see actually, an uptake in the use of technology to create artistic pieces. Do you see the same? What is your involvement with the artist community? What is this? Is there an intersection between engineering and art these days?
So we're celebrating, what, the 500 years of Leonardo da Vinci, right? Yeah, so I guess that's an example, right?
Yep.
We're in the right spot. The intersection of engineering and art, so it has existed since the beginning of time. You know, a good engineer is a good artist, and perhaps vice versa. The capability, so the machine runs on imagination, as I said. And who has some of the best imagination besides the children, right? Is those who are so creative in art and design, much better than myself. I can make a machine, but to come up with some of these geometries, it takes a special imagination. To be able to put that into the machine and create it in front of you and have that almost instant gratification of creating something, I think is as an example, we have an architect in Sweden who imagines on the side of the building a facade of people walking and movement, and they say, how am I going to create that? And there was no faster, better way than 3D printing. They actually 3D printed the molds and put the concrete in the mold, and they were able to build that building faster and at a lower cost using the 3D printing technology. So whether you're making the piece itself or you're making a mold or a form, what you're really doing is creating complex geometry faster and cheaper than any other technique available.
That's very interesting. So another thing that interests me, I mean, you say artists are very creative and you don't consider yourself an artist. But to conceive your machines, to conceive also the mission of Re3D, it takes a lot of imagination. Also to create the machine, it takes a lot of imagination. My question is, how useful is technology to realize your dreams? In particular, modeling technology, 3D experience. Was it helpful to go from ideas to reality?
You know, there was no two ways about it. For us, it was very simple. Having myself as a linear thinking, perhaps, and seeing that absolutely, in order to create this technology, in order to manufacture it, in order to bring it to life, the software was absolutely fundamental to making this happen. And as I said, we use Dassault Systèmes all the way from the beginning, from the first idea to when we started to sketch, to bringing everything and assembling it in the digital platform. There's no other choice in the modern day and age. If you want to be competitive and if you want to bring your product to market and if you want to share your ideas with the world, you have to utilize that digital design space. You have to utilize that digital thread that carries you all the way through to where you can hold that in your hand and say, hey, this is what that idea that I told you about, here it is. So there's really no other way to do it.
Thank you. Matthew, I have a million questions, but I think the audience may be interested in having a conversation with you. Anybody interested here? Otherwise, I keep going, okay? Okay? Oh, there is a microphone there.
Okay, so Matthew, I had a quick question. I know we have talked before. By the way, I'm Suchit with SolidWorks. You talked a lot about the sustainable printer, and that's your unique. I've not heard of another 3D printer with sustainable materials. How do you get sustainable materials? You talked about pellets. How do you create the pellets, and where do you get them from?
I think there's
I mean, as a customer, where would I get it from?
Yeah, for sure. With that technology, to be able to 3D print from pellets or ground up plastic, there's actually two paths. So the pelletized material can be a virgin material, and that's available all over the world. That's a commodity item. And the ground up material is perhaps the more interesting one for us. And that's available. I think there's some very early, easy wins for this technology. And I'll take a step back and say that 3D printing is not easy. Many times 3D printing can be hard. It's still a very young technology. And then you add recycling on top of that, it becomes even more difficult. The early win for us, and I think for many people, is actually diverting waste material from the landfill. So perhaps the first step is we go to manufacturers, you manufacture a product, you use plastics, and you have a waste. And perhaps you're paying someone to haul that waste off to the landfill. Well, let's divert that. It's a known material, it's a single source, it's clean and sorted. I think that's the easy win. And that we take that manufacturing waste, we experience the true circular economy right on your factory floor. And we allow people to make jigs and fixtures and packaging material, things that they use in-house already. I think that's the easy win. There's certainly more difficult ways. There's certainly more challenges associated with having the garbage either in the ocean or on the land, but we're taking steps and we'll get there.
Your key technology is really taking the pellets. Is that what it is?
So yeah, the core of it is the platform we call Gigabot X, and that's the machine that allows you to print. What will surround that is a family of products that will allow you to take that water bottle, that plastic cup, to shred it, to grind it, to dry it, to prepare it for the printing process. So in the end, there'll be a family of products.
But do you produce the filament created out of recycled material, or do you provide the shredded material?
No, I think we skip over that whole step. So the filament that's traditionally used in 3D printing, there's a lot of money and energy embodied in that material, and we don't need to go to that step. And if we skip that step entirely, it allows us not only to save money and time, but importantly on the engineering side, every time you heat up the plastic and you melt it, you degrade it a little bit. So if we can take that plastic and print directly, then we're about 3 steps ahead.
Oh, this is very new. That is very new.
Yeah.
Any other questions from the audience? So I have one last question then, because we are almost at the cusp of the time. Your company was a spin-off of NASA, right? So what were you doing at NASA? What is the interest of NASA for 3D printing?
It's interesting because my position and my co-founder's position at NASA were slightly different than the actual work that we're doing now. Even though I have a background in manufacturing engineering and being a tool guy, so to say, my job at NASA in the neuroscience laboratory was to help mitigate the effects of spaceflight on the astronaut crew. So before they flew into space and after they came back, and they experienced certain difficulties from the microgravity environment, it would change people physiologically. So we would work to mitigate those effects of spaceflight. And my co-founder was actually the deputy strategist for space life science.
Okay, wonderful. Okay, thank you very much, Matthew. So we've seen a very interesting story on how we can harmonize product, nature, and life. Please, a round of applause.